Hey, 8th graders, we are moving on. We are starting with our slope-intercept form today. This is probably my favorite form of linear equation. So just to recap what we did last Wednesday, it was a week ago already, we started talking about linear equations and linear functions in general. They are a straight line, so they can't have any sort of curve. We talked about how do we know which ordered pairs are on a linear function and they go on there. We tested them in equations. And then we talked about how we can tell by just looking at an equation and how we can tell by looking at a table. So then you guys had a little bit of homework there, and now we are going to talk about a certain form of equations, and basically you guys are going to work with slope-intercept form, standard form, and point-slope form. So like I said, this is one of my favorites. You use this a lot when you're graphing, and it really does make your life easier when you have to graph. So it says, consider the graph to the right, which of the following points are on this line? So you can simply take these points and you can go. So if I go 2, 0, is it on the line? Yep, it's right here. If I go negative 3, 1, 2, 3, negative 3, is it on the line? No. If I go negative 1, 0, is it on the line? No. So by doing this, you can go through and you can see which points are on the line. 5 and 1.5, yep. 6 and 2. So 6 isn't on here, but could you maybe predict where it was going to go? Yes. And then 8 and 3. So if we went over 2 more, I mean, you guys can kind of see what's happening. We're going up 1 over 2, up 1 over 2, up 1 over 2. So we can make this prediction even though it's off of our graph. So it says, even though points 6 and 2 and 8 and 3 aren't pictured, we can still be confident that they are on the line, just like we kind of made that prediction right here. So here is the real goal for the lesson though. Is the point 128.63 on the line above? How could we tell? We can't stretch that graph out that far, and if we were just kept on counting using the slope, that would take a while. So to answer this, we need to get more comfortable with linear equations. So slope-intercept form is one form of those linear equations. So it says, let's start by graphing one with a table. So we are given an equation, and we can make a table, we can put in some points, and we can get the y values. So by putting in an x value of -1, what's going to happen is we will just solve this algebraically for the y value. So -2 times -1 is +2 plus 3. So this would give us 5. That's our first order pair. When I put a 0 in, I get 3. -2 times 0 is 0, plus 3 is 3. When I put a 1 in, -2 plus 3 is 1. So I get 1, 1, and the last point, and these are really common numbers to put in to solve these equations. I think we've actually done this before. -4 plus 3 is -1. Our last one. And these are just to kind of get a general idea of our line. So if I go over to my graph here, I'm just going to plop these points on there. -1, +5, 0, 3, 1, 1, and 2, -1. You can see that line. I'll just connect my dots here. So that's one way to take an equation. You pick out some nice simple numbers and you can put them in and plot your points. So graphing linear equations with tables takes way too long. We did 4 problems just to plot those 4 points. What you notice about the equation y equals -2x plus 3 is that its slope is 2. If you took the slope of this, you'd go down, oh, it's actually -2, down 2 over 1, down 2 over 1, down 2 over 1. Your slope is -2, and it crosses the y-axis at +3. Now I want you guys to look at this equation. Do you see those numbers? Do they have something in common with those? So the reason why this is called slope-intercept form is because in this form, we are given the slope and the y-intercept. So this is, you might want to label these right now like I am. The B stands for the y-intercept, and the M is the slope. Okay? And the y-intercept is where it crosses. Intercept means to cross paths. So this equation you guys are going to get very familiar with, and we are going to use it to graph lines. Flip the page here. So we start off just warming you up to this idea. We are going to be looking at 4 different equations, and we're just going to pick out the slope and the intercept. I'm going to grab a highlighter here. So again, if our equation is y equals mx plus b, that y and that x stay there the entire time. It's the m and the b that we are looking for those numbers. So if I go through the first one, they're right there in front of us. The slope is 3, the y-intercept would be 4. The next one, the slope is a -2/3. The y-intercept, you have to remember that this is a plus b, so if there's a minus here, you have to include that as a negative. Now the next one, there's nothing in front of there. Do not say the slope is 0, because 0 times x would be 0. There is an understood 1 there, and we've talked about that before. Then my y-intercept would be 6. And then your last one kind of has both situations here. There's just a negative in front of the x. Remember, that's a 1. And if there's nothing tacked onto here for the b, that's a 0. So your slope is a -1. Your y-intercept is 0. What that means, if you glance just at this graph here, that it would go through the origin. It would start right there at 0, 0. So now we have just a much quicker way to graph. So how you start is you start graphing, you plot the y-intercept. That's where you start. So like this one is a -1, so I'm going to start right here at -1. And then use the slope to plot more points. So my slope is 3. This means 3 over 1. So I'd go up 3, 1, 2, 3, to the right 1, 1, 2, 3, to the right 1. And there are 3 points. And then please use a straight edge, a straight piece of paper, post-it pad of paper, whatever. Make a straight line there. And there is your graph. So there is how we can do it without having to make a table. So just to quickly review, because we're going to do a lot of graphing here. This 4/5 means up 4, right 5. This one 6. Remember, if it's a whole number, you just put it over 1. That means up 6, right 1. And this is because 6, they kind of show you right there. -3, you put it over 1. This means down negative, or down 3, I guess the negative means down, right 1. This means down 2, right 3. And they kind of show you got that kind of stuff too. So make sure you're careful with your slopes. So then we're going to go to our graphs here. And we are going to keep an eye on my time. We are going to graph. The first one, you start at the y-intercept, so I have +1. The slope is 2, so up 2 over 1, up 2 over 1, graph your line. Isn't this so much better than making tables? Your next one, you start at -3, 1, 2, 3. Your slope is positive 1/2, up 1 over 2, up 1 over 2. And then draw your line. Your next one, you start at +2. Your slope is a -5 over 1. 1, 2, 3, 4, 5 over 1. I don't really have any more room. I can't do another point on this one. Ideally, you would like to. Okay, next one, -2. So I start down here. Your slope is a -3/4. 1, 2, 3 over 4. 1, 2, 3, 4. You can also put the negative with the bottom number, so I could go up 3, 1, 2, 3, and then my left could be negative 1, 2, 3, 4. You'll notice that they are still right in line. So sometimes when you're limited on your graph with not being able to go down or up, you can do the opposite. So if there's nothing there, if there's no intercept, remember that's a 0. So I start right here, up 3, 1, 2, 3 over 2. So I can't go up 3, so I'm going to go down 1, 2, 3 over 2, left 2. And it's good just to do these along with me to get lots of practice. You can pause me and you could do them and then check with me to see if you get them right. So this one, notice I can't go up 4, and I want to go up 4 over 1, so I'm going to go down 1, 2, 3, 4. So that's a negative, so that means to keep this positive, I have to do another negative. Just lost my... And then double checking that I did it right. This is a positive graph and my slope is positive, so they go together. This one, remember, if there's nothing in front of the x, there's a 1. If there's no b, it's at 0. This graph is actually called a parent function. It's the most basic linear function. It starts at 0, 0, and it goes, has a slope of +1. Every type of function, whether it's exponential functions or linear functions, they all have a parent function. That's something we'll talk about probably next year. This one starts at -4. Now this again, I cannot go down 4, so I have to go up 4. 1, 2, 3, 4. That means my negative has to be with a 3. 1, 2, 3. Left is negative. Graph your point. So we just graphed those 8 graphs pretty quickly. You can imagine if we had made a table and if we had graphed, we've graphed 4 points with every table, we would have done 32 math problems by now. So this is a pretty nice strategy for graphing. Next page, we can also, if we can graph it from a line, we can write the equation from the graph. So again, you need to find the y-intercept and you need to find the slope of your line. So you're looking for those 2 spots in your graph that have perfect intersections. So I just circled 3 of them there. So in order to find this, I'm going to grab a marker here. My slope is a +1 over 3. So my equation would be y equals up 1 over 3 is my slope. My y-intercept is 2, so it's a +2. That's where I write my equation. Your next one is going to be negative. Notice my y-intercept is at -1 also. And if I'm just looking for nice intersections, I find one there and here it looks like. So if I was finding my slope, I'm going to go down 2 and right 3. So my slope, -2/3, and then like I said, my intercept was at -1. So instead of writing plus negative, I just write -1. The next one, I find my intercept, and then looks like my next point might be there. I can't even really see the other one, so this one would be up 1, 2, 3, 4. 1, 2, 3, 4, 5 over 1. Notice the larger the slope, the steeper the line, and it intercepted at -2. Okay. Next one, -4 is where, or +4 is where it crosses. You can see the slope is a -1, down 1, right 1. So y equals -1x plus 4. This one intersects at 0. And then you can kind of see where other points are. So I'm going to go down 2 over 1. My slope would be a -2, and my intercept was 0. So you could leave it like this, or you could write +0. Either way would be acceptable. You'll probably see it like this more often, but for your own practice, you could just do that. Last one, we had this one crosses at a -3, and the slope is looks like up 1, right 1, up 1, right 1, up 1, right 1. So y equals 1x minus 3. Okay, so now going back to the original, it says, is the point 128.63 on the line above? And we need to know the answer. Okay, I want you guys to take a second, think about that. What do we know? What have we learned throughout this lesson? Well, now we can't graph maybe this point, but can we come up with an equation for this graph? So maybe our first step would be to find equation of the line. So this one, which we'll just do y equals, it crosses at -1, and the slope is up 1 over 2. So 1/2 x minus 1. 1/2 x minus 1. So now that we know where it crosses, we know the equation, we can put that point into the equation. Test to see if point makes the equation true. Let's see. So if I take and I put my, this is my x, this is my y, 63 in, and half of 128 minus 1. Half of 128, well, half of 120 is 60, and half of 8 is 4, so this would give me 64 minus 1. Does 64 minus 1 equal 63? It does. So if it makes it true, then yes, 128.63 is on the line. So combining what we learned on last week, Wednesday, with what we just learned today, you guys are able to figure out if a point that's on a line or not, even if the graph is not large enough. Okay, so what you guys are going to do, after you fill these out with me, you are going to do the next 2 pages. It says slope-intercept form homework. So basically it's just exactly what we did throughout the notes. If you guys have a question, take a picture of it, email me, message on Google Classroom, whatever you need to do to get a hold of me. Hope you guys are doing great, and we will talk to you Friday.